Dear students, last class we have discussed the chemical properties of group 13 elements. So far we have discussed chemical properties of boron, that is up to reduction of boron trihalides. Production of boron trihalides. Boron trihalide reduced with metal. This reaction assisted by dihydrogen, then it forms tungsten boron tungstate, and then tungsten borate plus chlorine molecule, and then HCl is comes out. The last class we have discussed. Now we are going to discuss the remaining chemical properties of boron. See, for example, then one more another chemical properties, formation of hydrides. Before that we should know what is hydrides. The metal or a non-metal with hydrogen, that is called hydrides. Hydrides, which means hydrogen in the negative oxidation state. Say for example NaF, NaH, sodium hydride. Generally the hydrogen having a electron negativity character is high when comparing others, that means metal. For example, while comparing metal, alkali and alkali earth metal, hydrogen is more electronegative, and in comparing to non-metal, hydrogen is lesser electronegative. Okay, right? In case in such cases we can understand easily the nature of hydrogen. Here, formation of hydride. Boron is a non-metal. Boron does not react with hydrogen. Why? It is because already I have mentioned in the earlier session the similarity, the similar electronegativity, like boron possesses electronegativity, similar electronegativity with carbon as well as hydrogen. So that not only that, boron generally inert in nature, so that it does not react, it does not directly react with hydrogen. So in such cases what we are doing, it forms a variety of hydrogen. In such cases we are treating boron compound with metal hydrides, then it forms metal, what is that, hydrides. Sorry, not a metal hydrides, hydrides, boron hydrides. Generally hydrides of boron is called boranes, that is boranes அப்படினு நம்ம சொல்றோம். The simplest borane is diborane. Simplest borane is diborane. Generally the name formula is B2H6. B2H6. It can form higher diboranes from the initial product diborane. From the diborane it forms many diborane, higher number of diboranes. Larger boranes can be prepared from diboranes. The treatment of gaseous boron trifluoride, the first property, formation of hydrides. The gaseous product of boron trifluoride reacts with the sodium hydride in the presence of 450 Kelvin. Then it forms a diborane with a sodium fluoride. Due to pyrolysis, what will happen here to prevent subsequent pyrolysis? இங்க என்ன பண்றோம்னா diborane is trapped immediately. Pyrolysis, are you hear that word pyrolysis? Pyrolysis, which means pyro means heat, lysis na பிளவு. So heat அதிகமாகிறதுனால என்ன ஆகும்? Immediately the diborane will undergo fission. So to prevent the subsequent pyrolysis, it will be trapped immediately. Right? So this is the formation of hydride. Then one more chemical property is, what is that? Formation of boron trihalides. Boron trihalides with halogen to form boron combined with halogen, it forms boron trihalides. Say for example boron with generally X, which means halogen. Boron with halogen in the presence of heat, it will become boron trihalides. X may be chlorine, bromine, everything. It may be anything. Right. Next, formation of boron nitrides. Bn, boron nitride, which is the formula of boron nitride is Bn. So boron nitride with nitrogen molecular nitrogen or dinitrogen. Boron burns with dinitrogen, it forms boron nitride. Boron nitride, it's a very simplest reaction. Right, formation of oxides. Then formation of oxide. The remaining property, formation of oxides, reaction with acids and alkalis, that's and then uses. That's we are going to discuss in the next session. Throughout the session we have discussed there are three chemical properties of boron. It is very much important. Okay, right. Next thing we will discuss in the next class. Thank you.